Caution: extreme danger. The chemicals used in this experiment are extremely caustic and possibly lethal. Do not attempt without adequate experience and training. Sulfuric acid is harmful or fatal if swallowed or inhaled. Contact with skin causes severe chemical burns instantly. Use of the information portrayed in this video is at your own risk. Hello everybody, this is Scott here, Scott's Mad Science and More, and today I have whipped up a batch of a fun little kitchen chemistry thing. Looks extremely liquid, but it's actually what's known as a non-Newtonian fluid, which means that here, if I just let this sit here, completely liquid. But if I hit it with it, it's the end of a glass stir rod, completely solid. This is a non-Newtonian fluid known as Ooblek, mixture of cornstarch and water. How it exactly works, I don't know. But what a non-Newtonian fluid is a material that changes viscosity based upon the amount of work or force, one of those two, that is being applied to it. For example, I can take some Ooblek, put it in my hand, completely solid, as long as I continuously apply pressure to it. Then if I let the pressure go, it turns to a liquid unless your skin absorbs all of it, which mine did. Let me just move this tray of Ooblek back. Pretty interesting stuff. So now today, I've brought one of my favorite chemicals over, sulfuric acid, and I'm going to be seeing what happens when you put sulfuric acid on Ooblek. And this is extremely pure, known as reagent grade. So now, let's do this. Is anything going on? Okay, can it focus as zoomed in? No, it needs to be zoomed out a little. I don't think you can see it. My camera's also out of battery, but there's just a small line here. See what happens? I just move this around. It looks to be. Let's just add a bit more. And why not just add all of it? I will tell you this right now, if this was my skin, I would be in serious agony. Oh, that is very interesting. It's turning it from an acid, non-Newtonian fluid, such as this, where you can just hit it, to a goo. I'm extremely acidic goo at that. Now, I think I know why this is happening. So this raises the question, of course, of why does this happen? If you look back at the footage, you can see that it has turned into a completely liquid goop. Which is actually a very good question. Why does this happen? So I have done some research this morning. This is actually some older footage, so I've had plenty of time to research this. Here's what I have found. First, you have to know how Ooblek works. It's a phenomenon. The reason it gets hard when you apply force to it, as seen here, and it's soft when you don't apply force to it, is a phenomenon known as shear thickening. This shear thickening means that this shear thickening affects the solutions of particles suspended in a liquid. Now, as you can see here, this is what it looks like. Let me click on this because I'm using Google. I love Google. You can see here you have your molecules, your starch molecules, in your water. This is a scale model of Ooblek, extremely zoomed in, like you are looking at it under an electron microscope, and you can see that they're pretty evenly spaced, and there's water in between them. But now, everything is about to change. Everything changes when force is applied. According to a study at Cornell University, it is caused by friction and the compaction of molecules. If you want to see my source, I have included it right here. Link will be in the description. Let me show you. This is what, as you can remember, this is what Ooblek at rest looks like. When you apply pressure to it, everything changes. You now get it so you have molecules that are extremely tight together, touching each other, and the friction is causing them to have a harder time moving, which is causing it to become a solid. Now that we have learned how Ooblek works, here's what at least I think happened. Massive disclaimer, I am an 8th grader and am not trained in chemistry. The following information is just an educated guess of mine. Anyway, when the sulfuric acid is added to the mixture, the acid attacks the starch and breaks it down into simpler sugars. This is what happens when, at least this is what happens when hydrochloric acid is added to starch. The chemical formula of starch is 6 carbons, 10 hydrogens, and 5 oxygens. Move that in there. I don't know how to read this. As I said before, I'm not trained in chemistry at all. Don't know how to read this. What's this? Please tell me down in the comments if you know. Anyway, so it's just very similar to glucose. In fact, it's off by 3 molecules. It should be H12 and O6 if it was glucose. So my theory is that the acid broke down the starch and caused it to turn into glucose and other compounds. Now, the starch is no longer present, causing the mixture to no longer have the same properties, and thereby is no longer a non-Newtonian fluid. Back to you, Scott.
Alright, well, yeah, this has been it for this video. And stay tuned for future videos where I'm hopefully going to get my hands on some liquid nitrogen and freeze some Ooblek with that. Yeah, you can see it's a weird color now, too. Anyway, well, this has been Scott here, Scott's Mad Science More. Please be sure to like and subscribe. I finally have 19 subscribers at the time of the recording. Yay. Please subscribe, share on social media. And this has been Scott. Thanks for watching. Hope you enjoyed, and I'll see you next time. Bye-bye. Can you see my phone? Yeah, there. Bye-bye.